we present SurveyTwin, a framework for simulating personas with large language models. Survey data is crucial for research and policymaking, but survey response rates have been declining for years. Recent advances in AI technology have inspired the interest in using LLMs to augment survey responses with synthetic data. The goal for this project is to create a scalable framework for evaluating the fidelity of persona-conditioned LLM survey responses by using agent-based modeling to simulate and augment an interview-like situation.
As a result, we have created the framework we call SurveyTwin. This is a framework that simulates an interview-like situation with an interviewer and a citizen. To begin with, we have input survey data with human responses. This file contains demographic variables which we use to create the citizen agents. The data set we use is a combination of both survey questions and demographic variables. The demographic variables on the right are the ones that we use to create personas, which we assign to citizen agents. Meanwhile, the questions on the left are those that we ask the agents. In addition, the answers we have here are from human respondents. These are the ones we compare to the agent's answers. Something that you may notice is the format of the answers. We use the Likert scale, so it goes from 1 to 5. The cells with 9999 are those that were not answered. So the entry point of the program is in the application layer. Alongside the application layer, we got the LLM layer and the storage layer. The application layer creates an interview agent and a citizen agent. The interviewer asks citizen's agent some questions, which in turn prompts an LLM using the LLM layer. In our configuration, we use Olama. Once the model has answered the questions, the response is returned to the citizen agent, which in turn sends the response to the interviewer agent. Now, we are interested in analyzing the responses, so to do so, we want to save the data in the file system. We do this by communicating with the storage layer using its public interfaces. One feature of the framework is we are able to store persistent data. That means we are able to see how the answers from the LLM changes through different generations or evolutions. These are done with the database driver. This is a connection to a database management system like Postgres or MySQL. In our project, we use Postgres. Now that we have the persistent data and we have written the file to the file system, we now have the synthetic responses which our analysis consumes.
For this demonstration, we are running a limited simulation with just 10 personas and 15 questions running for 2 iterations. On the left side, we can see the interviewer in the framework asking questions to the citizens. And on the right side, we can see an instance of the Olama server running, which demonstrates when the LLM is getting a new request from the citizens. This version of the framework supports connection to a locally running LLM. If desired, the framework can be adapted to use other providers like Claude, ChatGPT, and different models available on Hugging Face. After the simulation has generated synthetic responses, we can feed these into the analyzer to visualize them. The first plot shows a simple comparison of how the humans and the LLM responded to the same questions. The blue line represents the synthetic responses, while the red dots represent the human responses. This plot shows how consistent the LLM is while answering the same question across multiple iterations. A low value means that the LLM is stable. A high value instead means that it changes answers a lot. The next plot shows how consistent the LLM responses are per respondent. The red bars represent respondents with unusually unstable predictions. This plot measures the mean absolute difference, or MAD, per question, or how far the LLM answers are from the human responses on average. A low MAD shows that the LLM is close to the human response, and vice versa for a high MAD. The error bars instead show how much variability there is across different respondents. The last plot shows the difference between LLM and human responses for each question. If the bar is above 0, the LLM has given a higher score than the human, and vice versa. In conclusion, we have introduced SurveyTwin, an agent-based framework for running survey simulations with large language models. It allows the control of several parameters like the model in use, the prompting strategy, population size and number of iterations, and it analyzes the resulting responses against human survey data. Thank you for your attention.